Hello friends, and welcome to a new session with edupediaworld.com, your favorite portal for online education. Continuing our discussion with correlation analysis, today we shall take up a special case of Spearman's rank correlation, and that is the case of tied ranks. Case of tied ranks arise when two or more individuals have the same rank. Let's take an example and try to understand what the case of tied ranks is. Let's say we have a variable x, and say x denotes the marks of 10 students, n equals 10, in a certain subject. Okay, let's list the marks, and the values are, say, 28, 27, 26, 25, 25, 25, 24, 21, 21, and 20. Okay, so now when we look at the numbers here, say this student, let me give roll number or serial number to these students: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these 10 students have secured these marks, and when we look at the marks, this student has scored the highest, followed by the next, and then here the third student. But then here we see that student number 4, student number 5, and student number 6, all the three have the same marks, 25. Okay, this is actually the case of tied ranks. If I have to give them ranking, quite obviously, since their marks are the same, I'll have to give them same rank. Okay, so there is a tie here. Same is the case here, where there are two students with a tie at 21. Okay, so here we see that there is a tie with 3 students. Okay, 3 students tie, and then here there's a tie with 2 students. Okay, now let's see how to resolve the tie. So each individual is assigned a rank equal to the mean of the ranks that would have been assigned to them in the event of there being slight differences in their values. So in case when there is a tie, what we do is we take the mean of the ranks which actually would have been assigned to them had their marks not been equal. Okay, for the rest of the values, no change would be made in the ranks. So let's see here. Let me assign the ranks to these students here. Quite obviously, 28 being the highest will get rank 1, next is rank 2, next is rank 3. Now in case of 25, 26, and 27, if I were to go in the same order, the student would get rank 4, followed by rank 5 and rank 6. Assuming that they do not have exactly the same marks, let me just assume that the marks of the student is, say, 25.5, followed by the next being 25.3, and the next being 25.2. Okay, had this been the case, I'll give them the ranks according to their serial number 4, 5, and 6. But now that's not the case, so what I'll do is I'll take the averages of their serial number or their rank in case if their marks were this. Okay, so the average here will be 4 plus 5 plus 6 divided by 3, there being 3 students, and that will be equal to 4 plus 5 is 9 plus 6 15 divided by 3 will be equal to 5. So I'll give them rank 5. So this student will get rank 5, this student will also get rank 5, and this student will also get rank 5. Is that clear? Yeah. So I'll be taking the average of their serial number or average of their ranks had their marks not been equal. Okay, but this is not the case, therefore the rank has to be equal, their marks being equal. I'm giving them rank 5. The next student, student number 7, will he get rank 6? No, his rank will be same as what we have here, rank 7. You see, this is 1, 2, 3. The next, this is serial number 4, 5, 6. There will be no change here, so this student will have rank 7. Is that clear? So no change in the serial order of those marks which is out of the tie, where there is no tie. Okay, wherever there is a tie, we will take the average of the serial in which they appear. So in following the same way, now for these two, we will again take the average of 8 and 9. So the average here will be 8 plus 9 divided by 2, and that happens to be 8.5. So the ranks here for these two students will be 8.5 and 8.5. Okay, and the last one, yeah, the last student will have rank 10 because there are 9 students above him. Okay, and coming in the serial order, we see that this student was supposed to get rank 9, so the student will have rank 10. So this way we assign the ranks to all the students. You see, there's a tie here between these 3 students, and then there's a tie here between these 2 students. Okay, and then further proceeding further from here, we will use the same formula for Spearman's rank correlation, which is given by rho, and the formula is 1 minus 6 times summation di square divided by n into n square minus 1. Okay, so we'll be using the same formula. We'll be calculating di square in the same manner as we did previously in case of Spearman's rank correlation. But since the Spearman's formula is based on the assumption of different ranks to different individuals, in case of tied ranks, its correction becomes necessary. We need to use a correction, and this correction factor is given by m into m square minus 1 by 12, where m denotes the number of observations tied to a particular rank. And this correction factor is used when we have completed the calculation of di square, and we add this correction factor to di square once for every tie. Okay, so let me explain this to you as well in the previous example. So here we have got the ranks. Next we will develop the difference of ranks with the other variable whichever we have. When we take a numerical problem, you'll understand that, and anyhow we know how to calculate the di value. Di is equal to xi minus yi. Here as of now we just have x, so we'll not be able to do that, but let's say we have got the value of di in the usual manner. We'll find the square of this and take the summation. Okay, once we have done this one, we will be adding correction factor to this, and the value of correction factor is given by m into m square minus 1 by 12. Okay, so it's m into m square minus 1 by 12. And what is m? M is the number of values tied in each case. Okay, so here we see in this case there are 3 values tied, therefore the correction factor which we'll be using for this will have m equal to 3. Okay, so and in this question, if you look at this question, there are 2 ties. Okay, one at this rank 5, another at rank 8.5. so we will have to find 2 correction factors, correction factor 1 with m equal to 3 and correction factor 2 with m equal to 2. Okay, so I'll have to find correction factor 1 where m is equal to 3 times the square of 3 minus 1 by 12, which will be equal to 3 multiplied by 8 by 12, and cancelling out we have 3 ones, and this will go 4 times, 4 once, and this will go twice. So correction factor 1 in case of the tie at 25, correction factor 1 will be equal to 2. Okay, similarly correction factor 2 will be equal to m, again here is 2, times the square of 2, which is 4, minus 1 by 12, which will be equal to 2 times 4 minus 1 equals 3 by 12. Again cancelling out, we have 1 by 2, which is equal to 0.5. So your correction factor 2 is equal to 0.5. Now what I'll do is I'll add my correction factor to this summation di square plus correction factor 1 plus correction factor 2. Okay, so you'll have summation di square plus 2 plus 0.5. okay, so whatever value you have in place of summation di square, to that we will be adding a correction factor of 2.5, and that will be used in the formula in place of summation di square. Okay, so let me say that your summation di, the new summation di square, new value will be equal to this. Okay, fine. So let's take some numerical problem and get used to this. Here we have a series A and B. Let's first assign ranks to both of them. Let me say that the rank to the first series A is X and the next series Y is B is Y. So here let's take the highest value. The highest happens to be at 65. So let me assign rank 1 to this, then 2, 64, 63 will have rank 3, 62 will have rank 4, then we have 59, 59 will have rank 5, 58 will have rank 6, 57 will have rank 7, and we see that there are two values at 57, so both of these will have, in fact this is supposed to be 7 and this is supposed to be 8. So what I'll do here is I'll take the average of 7 and 8, and that will be equal to 7.5. so I'll assign 7.5 to 57 and 7.5 here to this value. Okay, is that clear? And then lastly 55 will have rank 9. Okay, let me do it once again. You see here we're starting with the highest value. 65 will have rank 1, followed by 64, 63, 62, okay, rank 4. Then we have 59 which will have rank 5, okay, then 58 which will have rank 6, and then there are two values at 57. Their serial position is 7 and 8, right? This is at 7 and this is at 8. I'll be taking, let me put a color coding for this for you to understand. Both 57, there's a tie, so this is supposed to be in the 7th position and this is supposed to be in the 8th position. I'll take the average of 7 and 8, and that happens to be 7.5, which I've written here. And finally the lowest of all, 55, will have rank 9. Is that clear? Yeah. Coming to series B, let's see which is the highest. The highest happens to be 130, so let's give rank 1 to this, followed by 129 which will have rank 2. Then there are two values at 126, one at 3rd position, another at 4th position. Taking the average of 3 and 4, yeah, it's 3.5, so the values here would be 3.5 and 3.5, the rank of these two. Okay, which is the next in serial after 126 is 117, that will have rank 5, followed by 116 which will have rank 6, then 113 which will have rank 7, then 112 will have rank 8, and finally 111 will have rank 9. Okay, so these are the ranks of x and y. Next, in the usual way, we will find the value of d, which is the difference between x and y. So that will be the value here minus the value here. Okay, and then doing this for all the cells, we have the values of d for all these, and then we will find the square of d. Square of d will be this value raised to power 2, and dragging it down to all the cells, we have them here. Okay, and then I'll be adding them up to find the value of sum of di square. Let me write here sum of the values of di squared will be equal to, okay, so we see that the sum of di square is 3. Next, what I need to do, can I take it as it is and use it in the formula? No, we will have to use the correction factor. Okay, and how many correction factors are we going to use? We are going to use 2 correction factors, one for the tie at 57 and another for tie at 126. Okay, so let's do that here. We have 2 ties, one here for 57, okay, and for 57 the value of m, let me write it here, tie at 57, and this is on series A. Okay, we have a tie for how many numbers? 2 exactly, so m is equal to 2, and the correction factor for this, let me call this as correction factor 1, will be equal to 2 times the square of 2 minus 1 divided by 12. Okay, so the value will be 2 times 4 minus 1, which is 3, by 12, and that's going to be 0.5. so that's my correction factor 1. What about the correction factor 2 for series 2? For series B, we see that there is a tie here at 126. Okay, so we have a tie at 126, and how many numbers are tied? Again, there's a tie with just 2 numbers, so my m is equal to 2, and my correction factor 2 will again be equal to 2 times the square of 2 minus 1 by 12, which is going to be 0.5. so we have both the correction factors as 0.5, and my actual value of di square will be equal to my old value of di square plus the first correction factor plus the second correction factor. Okay, well, now what is the old value of di? Let me write this as new and as old. Okay, so my old value of di square, which we calculated here, is 3. Okay, so it will be 3 plus 0.5 plus 0.5, and that's going to be equal to 4. Fine. If you want, we can do it here also on Excel, but since we've already done, and it's trivial with small numbers, not very complex calculation, so we really don't need to repeat it here. So your value of di square is 3 plus 1, 4. Okay, now let's do the calculation, the final calculation. So your rho is equal to 1 minus 6 times of summation di square divided by n into n square minus 1. And what is the value of n? The value of n in our case is equal to 9. Okay, and here in this formula, the summation di square, I'm going to use this summation di square new, which is equal to 4. So my rho will be equal to 1 minus 6 times di square, which is 4, divided by 9 into the square of 9 minus 1. Okay, now that's going to be 1 minus 6 into 4 is 24, divided by 9 into square of 9 is 81, minus 1 is 80. Okay, so it's 1 minus 24 divided by 9 into 80, which is 720. And when you calculate this, the value will be equal to 0.967. Okay, if you want, you can check the answer here on we have the row value here, and that's equal to 1 minus, we have the numerator as 6 multiplied by 4, okay, and that's divided by n into n square minus 1, n is 9, okay, multiplied by 80. And that's equal to 0.96667, which is exactly what we have got here. Okay, so we are done with it, and this is the case of tied ranks. With that, we conclude the session on Spearman's rank correlation. For the other topics, keep watching Edupedia World videos. Thank you.